Here's a brief overview of how electricity can be generated through various methods. Light, photovoltaic, PV, or solar cells convert sunlight directly into electricity through the photovoltaic effect. When photons from sunlight strike the PV cells, they generate an electric current. Heat, thermoelectric generators, TEGs, can produce electricity from temperature differences. They utilize the Seebeck effect, where a temperature gradient across a thermoelectric material generates a voltage. Friction. Triboelectric generators convert mechanical energy from friction into electricity. When certain materials rub against each other, they gain or lose electrons, creating an imbalance that can be harnessed to generate an electric charge. Pressure. Piezoelectric materials generate electricity when subjected to mechanical stress or pressure. The pressure deforms the crystal structure of the material, causing a separation of charges and generating an electric current. Chemical action. Batteries and fuel cells are examples of devices that produce electricity through chemical reactions. In batteries, chemical reactions convert stored chemical energy into electrical energy. Fuel cells, on the other hand, generate electricity by combining a fuel, such as hydrogen, and an oxidant, such as oxygen, through an electrochemical process. Magnetism. Generators based on electromagnetic induction use a changing magnetic field to induce an electric current in a conductor. When a conductor moves through a magnetic field or when a magnetic field changes around a conductor, an electric current is generated. Motion. Generators driven by mechanical motion, such as turbines or generators in power plants, convert mechanical energy into electrical energy. For example, in hydroelectric power plants, the force of moving water turns turbines, which in turn rotate electromagnets within generators to produce electricity. It's important to note that these are simplified explanations of each method, and the actual processes involved can be more complex. Additionally, the efficiency, scalability, and practicality of each method can vary depending on the specific application and technology used.